All right, and today is the 20th, so I can change this. Okay, so as far as your graphical addition worksheet, I'm going to start to go through that, and things were a little chaotic that week that we were doing that, 'cause some people were here, some people weren't, and so I'm going to say there's a little bit of leniency for everybody who was here to do that. I can't get too lenient. Like, if you are really wrong, the best leniency I can offer you is maybe instead of saying, okay, I'm going to mark this down, to say, okay, this one is really wrong, you need to get it corrected, and then turn it back in so I can, get you full credit on this. But the goal on that one, well, really the goal of all of this is so that you become more comfortable with what vectors are conceptually and how to work with them mathematically, so that next week when we transition to actual applications of vectors in the realm of physics, you will see some problems that are just like this math thing. It's like, oh my God, this is like just what we've been doing last week. And there will be others where it's not exactly like what we've been doing here this past week and a half, but there will be some aspect that you need to be comfortable in your head of with the idea that, okay, I have one vector in this problem that, or maybe more, that doesn't point in a given dimension, and so I'm going to have to break it into component pieces so that I can actually start to combine vectors. So that's really the goal of all of this stuff that we've been doing, to hopefully deepen your understanding and kind of comfort level with vectors, so that when someone says, hey, that's between dimensions, you need to break it into pieces, that you understand what that means. Okay. Now, as a quick review, if anybody has anything left to do on the 10 vectors to break into components, I am going to be picky on formatting on this, because I did ask for, I'm just doing this one again because I remember the numbers. I asked for specific things. One of those was a quick sketch of the vector, with it broken into the components, and this picture, again, conceptually needs to be correct. If you draw me this picture and the angle here is, 155 degrees, I'm going to ding you on that one, because I want to be sure that when someone says a given angle, in your head you're going, yeah, that point's 155, that way. The second thing to really hammer this home is that when you did this calculation, even though you could probably tell me, look, it's cosine for the x component, y for the, or sine for the y component, on these, I want you to write out specifically the multiplication that you were doing with the correct trigonometric function to get me these answers. Okay? And I said these guys here, I want them rounded to the nearest hundredth. All right? You don't have to write this, but your answers need to be rounded to the nearest hundredth. So those aspects I'm going to be, scrutinizing when you turn this thing in. So if you need to go back and double check, you double check. The other thing I did say is, remember, and this is there is a difference between collaborating and copying. The collaboration is, you should check these numbers with a few other people, because they should be exactly the same for everybody. okay? If there is a discrepancy between a number that you have and a number that, you know, somebody that you're kind of double checking with, somebody's wrong, okay? And it could be a minor thing like, you forgot to round properly at the hundreds. If you're really off, you know, one possibility is, were you in degrees instead of radians when you were doing your calculating? But these things here, again, this was really repetitive work, again, to try and get you comfortable with whenever someone says horizontal, you're thinking it's the cosine function that I need to use to get there. And if you're talking about a vertical piece, then it's the sine function. Okay? So if you have not finished this on the paper that I handed back to you, you need to be sure that you get that finished, because you're going to need all of these to go to the next step. Okay? So I'm going to erase this now. Now, I'm going to walk you through what I want to see on today's assignment. Your assignment is to do the same 3 vector addition problems that you did graphically, but to do them mathematically. And one of the reasons that I am doing this is so that when you get your graphical worksheet back, because a lot of people said, did I do this right? You know, and really, if you don't know the right answer, all I can tell you is, did you follow the instructions and draw the picture or draw the problem the right way? And were you meticulous about doing it? If you did that, within the ballpark, you should be there. Mathematically, you don't have to do any picture, you just have to do the math right. And this is the more accurate answer for those 3 problems. So when you get to these answers, I'm not going to give you your graphical addition page back, but if you kind of remember some of the numbers you had as your answer, you know, hopefully you'll be going, yeah, that's about what I had. And if you're going, oh God, this is way different. Either you messed up the math part, or if you are rock solid that you did that right, then you messed up the graphical part. And when that happens, again, based on what I said earlier, I'll do my best to say, okay, this is wrong. I'll hand it back to you. And you can have a chance to kind of redo that. Okay, so one of the problems, or the first one that I gave you, was b plus I. So to do this mathematically, and this is kind of a review, if we were starting from scratch, and we laid out these steps yesterday, what is your first step that you would have to do? Is this where I can say, if I was doing this in 6th period, they'd be giving me an answer right away because they're so chatty. For those that know people in 6th period, they always complain that because I video this class and not them. They're upset. Okay, what's the first step that we laid out yesterday for doing a vector addition problem? Resolving the vectors into horizontal and vertical components. You guys are already done with this. That's on that piece of paper that I just handed back to you. So you don't actually have to show me that again. What was the second step?
Adding them up.
Add up, and what's the specific things that you're adding up?
Rx and Ry.
What you would like to get is Rx and Ry, and to do that, you just add up all of the X pieces of your problem and all of your Y pieces. So this is what I would like to see. I'm going to write, that's what you're supposed to do. I'm going to do this in a different color. you do not have to write this out, but I want you to put the values from that sheet that you have right there into this, so that you don't have to write out bx plus ix, but I want you to write the numbers from that sheet that you have in this place here. And then you are going to give me that answer. And the same goes here. I want you to put the values from the sheet that you have in there. Okay, so not so much conceptually, I think you get the idea of what you're doing, but I want to see the actual numbers that you're going to be adding together. And remember, some of these could be positive, some of them could be negative, because remember, the idea is that you always add all of the horizontal and vertical components together, and if there is any subtraction that needs to happen, it's not because you have to create a picture and go, yeah, this one points to the left, so I need to subtract these two. The subtraction will happen because you will be adding a negative thing in this mathematical expression. Okay? So, this is all I want to see. Now, for this problem, it'll be kind of basic. When you get to the last problem, I want to see 5 numbers that you're adding together, and then the final value. And remember, this is nearest hundredth. Everything we're doing is to the nearest hundredth. Once you finish this step, what was the next one? Come on, you guys remember this? 24 hours ago. Right. What is it that you figure out about your answer if we're doing vector speak? What is it that you're figuring out when you're doing this Pythagorean step? What part of your vector? R without the arrow, which means what thing about your vector? The length. Give me the M word. The magnitude. Okay? So this is what I would like to see. I just want to see the values substituted in, and then the answer. Okay? What's the last step?
Arctangent.
The arctangent. And what is it that you have to know in order to eventually get this completely correct? What do you have to figure out from some of this work that you've done here so that you know how to officially get the right answer for this one?
Rx and Ry.
Okay, you need Rx and Ry. We already have that. But then what else are you going to have to do? Nick?
Find the signs. What quadrant it is in?
That's okay. You need to figure out what quadrant it's in, and you should know that by the time you get done with this if you're already going, oh yeah, now I know which way it points. Why is that critical?
So you can put a sign on the R magnitude?
Not quite. Let's lay this out. Okay? I want to see the setup, but not with the Ry and Rx, but with the actual values, which are the values you would have calculated up here. What is it? What was the detail that we added after explaining this one?
The calculator doesn't pick up quadrants.
Correct.
2 and 3.
Right. The calculator won't really give you a quadrant 2, quadrant 3, and even for quadrant 4, it's not going to give you the angle in the form that you want it, because it will not give you that angle from 0 to 360. It'll give it to you in the form of a negative number of degrees. So this is where you need to remember, what are the 3 things that you might have to do with this answer to get the angle right? What's one possibility? Thomas?
Add 0.
Add 0. What quadrant does that correspond to? 1. If you are in quadrant 1, as soon as you do this, you are done. What are the other possibilities? Go for it.
Adding 180.
Adding 180. Where would you be doing that? Quadrants 2 and 3. Whatever you get from this, you add 180 to. And then the last one? Right, and that corresponds to which quadrant? 4. Okay, so this is what I am going to expect to see. You're going to do this, but added on to this, you're going to get a certain number of degrees, and then I want to see that notation. I used to go a lot pickier than this, and sometimes up here I would actually tell people, once you finish with these 2, I want to see a Roman numeral so that you can tell me what quadrant is your answer pointing in already, so that when you come down here, you know which one of these things to use. But I want to see, even if it's add 0, I want to see that in there as a recognition that you have kind of worked your way through what quadrant does your answer point in. Now, after you've done all of this, what do you do to summarize all of it? Anyone want to take a guess on this one? Really simple.
You just use the polar coordinate form.
Right. Somewhere around here, you are going to finally do that officially. Okay? Because all of these are just pieces to working towards that. So if someone said, where is your boxed in answer? That's your boxed in answer. But this is all the work that ends up supporting what you put in there. And I'm just going to put this here. Remember that that thing has units. In this case, it's just centimeters, because we are just playing with lengths of arrows. Okay. Any questions on this? All right. So this is all mapped out for you. When you go to the 3-vector problem, you're just going to have one extra thing in each of these. These 2 are going to end up essentially being the same format, because having 3 vectors doesn't add any complexity to this. It only adds one extra, component that you have to include in each one of these. When you do the 5-vector problem, this will become a little bit longer, but once you get to the end of this, these 2 steps look exactly the same. Okay? All right. So this was your first problem. Just to review, the second one is this, and the third one is I think I'm still on the whiteboard, is that one. So between today and tomorrow, your job is to do this mathematically, and if you needed any time to finish anything graphically, you should come see me and we can grab your graphical stuff. But the idea is that all of this stuff stays here. It's not going outside the classroom. So if you need an extra piece of paper because you used up a lot of room on the vector resolution, there's extra printer paper here. And if you happen to have fit everything onto one side of the printer paper for the vector resolution, I think you can easily fit these 3 problems mathematically onto the back side of that. Okay? And if you need a second piece of paper, it's right there on the front desk, and just remember to staple that together so I can get it back to you tomorrow. Any questions? Okay, and I'll try and get this listed as an official assignment on Google Classroom with, graphical and mathematical addition of vectors, with the turn-in being tomorrow, and the idea is tomorrow at the end of class. All right, so you guys got the rest of the period to work.